Okay, so I thought I'd try a different color scheme for today. So the first thing you got to do is when you see this question, you see you have 2%, 69.9% iron and 30.1% oxygen. So the first thing I do is I convert my percents to mass, and the easiest thing to do is to imagine as if to use 100 grams as your total, because it makes your math nice and easy. If you have 69% of 100 grams, you're going to have 69.9 grams of iron divided by, and so I'm going to figure out how many moles of iron I have here. So I'm going to convert my mass to moles. 85 grams per mole equals 1.252 mole. Good. I'm going to repeat that exact same step now, and so I'm going to do 30.1 grams because I took my percent, and I took 30.1% of 100 grams, which would be 30.1 grams. I know, the easiest math. And that's of oxygen. I'm now going to divide it by the molar mass of oxygen, which is 16 grams per mole. And that's going to give me 1.881 mole. So now what I need to do is I need to set a ratio. So what I'm going to do is I'm going to use my two numbers that I got, and I'm going to set a ratio. I'm going to write the ratio as the ratio of iron to oxygen. Why did I write iron first, you ask? Well, because in compounds, metals come first in the formula, so it's iron to oxygen. So now I'm going to write it as a ratio, and I know that my ratio is going to be 1.252 mole to 1.881 mole. What I do now is I take this and I am going to use, there we go, just move those up a little bit, and I'm going to use these numbers to figure out the lowest ratio. So I look at the two numbers and I think which one's my smallest number, and I'm going to divide by the smallest number to reduce to a whole number. So if I divide 1.252 by 1.252, do this, I'm going to get 1. I have to do the same step over here. I'm going to get 1.5. And that doesn't really work. We can't round up with that. So what we're going to do is we need to think of a better way to represent this. And you can't have a decimal. So what if I took this and multiplied both sides by 2? Now I'm going to get 2 to 3, which makes my empirical formula. I'm going to write it off to the side here. And I'm going to have Fe2O3. So the next step is if you figure out the formula using what you just saw, and so I figured out the empirical formula of my compound to be CH2O. Now I need to figure out my molecular formula. The molecular formula is some multiple of my empirical formula. Commonly with the molecular formulas, they're for covalent compounds, and this one's an organic molecule, so these are very good examples or common ones that I'd use. So I'm going to find capital M of CH2O, and I'd do that off to the side, and I'd get 30.3 grams per mole. So I ran out of room there. So now what I'm going to do is I'm going to use this to compare, and I know that in my actual molecule, the actual molecule has a mass, or a molar mass of 150 grams per mole, and then I'm going to take my empirical molecular mass, and which is 30.03 grams per mole. I'm going to divide. So this right here is the molar mass of the molecule, or the molecular formula, and this is the molar mass of the empirical formula. When I do the math, I get 4.995, and I'm sure you're going to agree that this is so darn close to 5. It's not funny, and we're actually going to use that as 5, and that's our multiplier. So our molecule is 5 times larger than the empirical formula. So you can think of it as CH2O, and there's 5 of them. Therefore, our formula is going to be C5H10O5.